Hello everyone, welcome back to Coding Charms. In today's video, we are going to be solving the problem maximum points on a line. So in this problem, we are given an array of points where points of I equal to xi comma yi represents a point on the xy plane. Return the maximum number of points that lie on the same straight line. The problem statement is pretty clear and easy to understand. So we are basically given with some points where a point represents xi comma yi, and we have to return the maximum number of points that lie on the same straight line. So let us take a look at the examples. In the first example, we are given with the points 1 comma 1, 2 comma 2, and 3 comma 3. All three of them can lie on a same line. So we return 3. And then we have points 1 comma 1, 3 comma 2, 1 comma 1, 3 comma 2, 5 comma 3, 4 comma 1, 2 comma 3, and 1 comma 4. So first 3 points 1 comma 1, 3 comma 2, and 5 comma 3 can form a single line. And then we can form another line as well with 4 comma 1, 3 comma 2, 2 comma 3, and 1 comma 4. So the maximum points lie on this line. So the maximum number of points 4 are 4. So we return 4. So what will be the naive or the brute force way of solving the problem? So let's see. What we can do is we can iterate over all the points for all points. We can iterate over all the points and keep a point P1. And then we can iterate over all the other points. Let's keep P2. And now we can form a line between P1 and P2, and now we iterate over all other points. Let's say we span this as P3 and check if P3 lies on the line formed by P1 and P2. This is P3. P3 lies on P1 and P2, and then keep track of a counter variable and increment the counter. So what will be the time complexity of this approach? Firstly, we are iterating over all the points, and then again we are iterating. Here also we are iterating. We have three loops, three nested loops. So the time complexity will be O of n q. And here we are only using constant variables. So the space complexity of this approach will be O of 1. So can we do better? So we have to find a way so that we can remove this inner loop, and then we can reduce the time complexity to of n square. Let us see how we can do it. So let me bring up the whiteboard. And I have considered some points here. 2 comma 1, 4 comma 1, 3 comma 2, 2 comma 3, and 5 comma 2. So let us consider one point. Let's say it as 4 comma 1, and let us draw the lines that are that 4 comma 1 is a part of. We have one line over here and another line here, and then we have another line over here. And now there is a concept called theta. Theta is equal to a tan 2 of y comma x. This is nothing but theta is nothing but the angle between a line and x-axis. So let us consider this as line 1 and line 2 and line 3. This will be theta 1, and this will be theta 2, and this will be theta 3. So how we can use the theta value for our advantage? Since all the lines have different theta values, and all the lines have different theta values, so how can we use it to our advantage? Let me make it smaller. So firstly, we can consider a point, and then we can iterate over, let's say it as point I, and we can iterate over all the other points. Let's say them as pj. Let's consider one as pj. Now we can find the theta value between pi and pj. How can we do that? So for that we use a tan 2 function. There are already inbuilt implementations of a tan 2, so you can use them. So to a tan 2 function, you can pass a tan 2. It is similar to slope. We pass y2 minus y1, comma x2 minus x1. And now we can have a frequency map which keep tracks, which let's say it as count, and its key value will be the theta value, and its value will be how many number of points pj which have this theta value, number of points pj which have this theta value uh, when they form a line with pi. So we do this, and finally we take the maximum number of points with some theta to pj. So for pj, we have maximum number of points for some theta. Like this we do for all the points, and finally we take the maximum number of points pj. Then we can return it as our answer. The things will get more clear when we look into code, when we code them up. So let us code it up. Let me remove this. And firstly, let's take n, which represents the number of points, and then let's have a result, maximum points. Let us initiate with 0. And now firstly we have to iterate over all the points I plus plus, and now again we iterate over all the other points, and now we don't consider one point twice, so we remove I equal to j condition, and now we have to compute the theta value. So theta value in Java we have math dot a tan 2 to calculate theta value. So it takes y2 minus y1 points of j1 minus points of I of 0. This is y2, sorry, 1. This is y2 minus y1, and next argument is x2 minus x1. So j of 0, points of j of 0 minus points of I of 0. x2 minus x1. Now we get the theta value. Now we have to have some kind of map. So let us initiate the map. Integer, comma. This will be, let's name it as theta counter equal to new hash map of, let's keep it like this, simple. And now let us put the theta value in theta counter dot put theta, comma, theta counter. Let's use dot get or default function and get the theta value. If there is no theta value already, we get 0, and then we add 1. And after this, here we take the maximum value. So maximum value for the pi. This will be the maximum value. So let us keep it current max points equal to max dot max. We have to use collections dot maximum of theta counter dot values, and finally, okay, this should be and then we take the maximum max points equal to max of max points, comma, current max points, and finally we return max points. Let us run it. Yeah. This should be double value, right? The key is double. It is none it. This should be maths maths in Java. Why is it given? Okay. So here we also have to add the current point. Here we also have to add the current point, right? We are only calculating other points. It got accepted for the sample test cases. It is submitted. Okay, so if we have only one point, then we can directly return that point. We don't have to perform any computations. Let us submit. It got accepted. So let us look at the time complexity. So here, firstly, we are iterating. Let me open the solution. Okay, so firstly, we are iterating over all the points, and then again, we are iterating. So we have two nested loops. So the time complexity will be O of n squared, and the space complexity would be O of n, because we are using one hash map. So that's all for today's video. I hope you understood the problem. It is a little tricky to understand the math and the calculations, but I hope I made you understand it. So if you did understand, make sure you hit that like button. And if you have any doubts, feel free to comment them down below, and make sure you subscribe to the Coding Charms YouTube channel for more daily videos. Thanks for watching. Keep practicing. Bye.